Hello, class. So today we're going to finish up with our polar coordinates. Yesterday we looked at how to graph polar coordinates, how to take those polar coordinates that are given to us in that r theta coordinate and then turning them into those rectangular coordinate planes in that Cartesian plane. So today we're going to look at doing just the opposite. So today we know that our rectangular coordinates give us that x and the y, right? And we know when we learned yesterday when it comes to polar coordinates, they're giving us r and that theta. So yesterday, I think I have a pointer. Maybe I don't. Ah, or not. So yesterday, we took these polar coordinates and then we were able to make them into xy coordinates. So now we're going to do just the opposite. So today, they're going to give us those rectangular coordinates. And we want to convert them into polar coordinates. So they're going to give us x and y. And we want to be able to convert that into r theta, right? So yesterday we kind of went through and we talked about looking at how we had that right triangle, and we could use that right triangle, and we can use our laws, or we can use our trig ratios to kind of help us with these. So yesterday we knew that x squared plus y squared equaled r squared, all right? And then we use some sine and cosine on that as well. So for us, this is really kind of helpful because they give us x and y. So they're going to give us this x and the y. And we know that that equals r squared. So we can actually solve it for our r, which is great news. The other piece is now to find our theta. So we have to figure out a way in which we can find that angle theta. And they give us x's and y's. So if we think of our trig functions, our sine, cosine, and our tangent, so real quickly, if we just kind of write it over here, cosine theta is going to give us x over r, right? Sine of theta is going to give us y over r. And tangent of theta gives us y over x. So for us, they give us x's and y's, so now we want to use that tangent. So in order to figure out our tangent, or to figure out our theta, we know that the tangent of theta equals y over x. So we can use those to help us find our theta. So on these ones, we're looking for all those x's and y's. Those x's and y's, we can use that to get our r. We can use these x's and y's in order to get our theta, right? So let's look at an example of this, and maybe if we throw it all together, it might kind of help all of us. So, oops, I'm going to slide. Oh, no, I'm not going to slide these guys. I'll slide some guys out of the way. So I'm going to write our little formulas down up here again. So we had x squared plus y squared equals our r squared. And we also know that if we use that tangent of our theta, we can have our y over our x. So let's say they give us an xy coordinate plane, or an xy coordinate, and they tell us that xy is... for that xy, they tell us they're going to give us our x is -1 and our y is the square root of 3. So they want us to take this and convert it into polar coordinates. So they want us to convert that into r and theta. So to figure out our r, we're going to use this guy up here, right? So x squared plus y squared equals r squared. So we have what? -1 squared plus the square root of 3 squared equals r squared. -1 squared is 1. Square root of 3 squared is 3 equals r squared. r squared is going to equal 4. We're going to take the square root of both sides, and we're going to get a positive and a negative 2, but since we're talking about the radius and that distance, we know it's going to be the positive 2. So we have now ended up finding what our r is, and our r is 2. So now we just need to find our theta. So we're going to use the tangent of theta equals y over x. So the tangent of theta equals our y, square root of 3 over negative 1, right? So I'm going to leave it written this way. And now I want to use, because yesterday you guys went through and you filled in all of your tangents onto your unit circle. So I'm going to pull this over here. And I ended up coloring on it a little bit. There we go. And let me blow it up. I think, maybe I can't make it bigger. Well, guess not. Zoom in if you need to, right? Squint your eyes. So, we need to find when we have that negative square root of 3. So, negative square root of 3 happens in 2 places. It happens up here in quadrant 2, and it happens down here in quadrant 4. So, we need to figure out which one of these we're looking at. So we have to go back to where this is our y value and this is our x value. So our y value is that positive square root of 3 and our x is negative 1. So between quadrant 2 and quadrant 4, which one has a positive y and a negative x? Well, that would be this guy up here, right? So that's in your quadrant 2. So we know that we're in quadrant 2, right? So I'm going to write that over here for a second. So we know we're in quadrant 2. And then what's my theta value in quadrant 2 for the tangent of negative square root of 3? That would be that 2 pi over 3. So then we know that our theta is 2 pi over 3. So we can fill that in. So we know that it's the coordinate point 2 pi over 3. And now we have that switched into polar coordinates. So some of you guys might be asking, going, well, why can't we use sine or cosine? And you kind of can, but this is what happens though. So let's say instead of using the tangent, because you guys didn't take the time to fill in the tangent, so you're like, I don't want to do that. I just want to sit there and use sine or cosine. And if we were to use, say, cosine of theta, cosine is going to be x over r. So when I put in my cosine of theta and I put in my x over r, my x is negative 1, and we found out that our r was 2. So we're looking for that cosine when it is a half. So where is our cosine a half at? Well, I have another little unit circle I could pull in here, right? And if we're looking for that cosine of being negative half, we know that because x is negative, it's either going to be in that second quadrant or it's going to be in the third quadrant. But the only thing you know is that it's negative half. So is it the second quadrant or is it the third quadrant? So you can't just use the cosine. And the same thing happens if you use just the sine. We'll throw it over here. If I use sine of theta, which is my y over my r, sine of theta, y was the square root of 3 and r was 2. So you're looking for that that positive square root of 3 over 2. Well, when is your sine positive? Well, in 1 and 2. So it's either 1 or it's here in 2. So you don't know which one it is. Now, granted, if you did both of those together, that's going to tell you that it was in quadrant 2, right? Because this cosine of negative 1/2 is either in 2 and 3. This is either in 1 or 2, so it only can be in quadrant 2. But now you're doing two of these to figure out, where if you fill in all of your tangents, you're just doing it once. So it's really your choice which way you want to do it.